In this section 4, it's about returns to scale. Naturally, we wish to know how an increase of both inputs affect outputs. But there are many ways of increasing both inputs. So I can increase labor by a bit and capital by a lot, or labor by a lot and capital by a bit, or both by equal amount. To avoid the distractions due to the substitutability between these two inputs, we would consider an increase of both inputs equally, or by the same proportion, or we call it the same scale. And these are the definition of the return to scale. So there are 3 different types of return to scale. The first one is the increasing return to scale. Pretty much the idea is that if we double all the input, then the output will be more than double, increasing return to scale. Constant return to scale, if we double all the inputs, then the output actually come out double, right? Exactly equal. Decreasing return to scale, double all the inputs, but the output actually are less than double. That's a decreasing return to scale. So if this is the first time you see this, or you might not be able to really get your head around it. Just I can give you some like numerical examples to make it more clear to you. Okay, let's suppose that we have okay, suppose we have labor and capital. So these are 2 inputs. This is the output from the amount of L and K. So let's say that I have L and K, I have 1 unit of L and 2 units of K. And then I got the output equal to 10. And then I double both L and K. So that means that now I will have 2 units of labor and 4 units of capital, right? What do I expect the amount of output? So if my amount of output comes out double, right? So you have double this and the output is so double. That means that this is a constant return to scale, right? Just everything double, right? But if instead I double my L and double my K, and my output actually only 15. So this is less than double. My output is less than double. Imagine that I increase both L and K double, but my output come out less than double. Less than what I would expect. This is called decreasing return to scale, right? If my output is 25, right? More than double. This is increasing return to scale. Increase L and K by double, but output comes out more than double. This is increasing return to scale. So that's pretty much what it is. So you can also write something like, okay, if I have K, let's say Q1, 2, right? Oh, sorry, I should put LK. Okay, Q1, 2. That means L equal to 1, K equal to 2. Q1, 2 is equal to 10. And I found that Q24 is equal to 25. If I see this, I know that this is because, right, I have increased both L and K at the same proportion, which is double, but my output comes out more than double. So which only this, suppose that I don't know this, but instead I have this information, then I can still say straight away that this is increasing return to scale, right? Or I can just put something like 3 and 6. So if instead I change this, what does it mean? That means that now I actually increase both L and K by 3 times, right? By 3 times, but my output come out less than 3 times. Because in this case, this is decreasing return to scale, right? You don't need to be double up. It could be triple, 4 times or whatever. But as long as it increase in the same proportions and the output and then you compare the outcome or the output. If the output, increase in the same proportion, then it's a constant return to scale. If the output increase less than that proportion of the increase in the input, then that would be a decrease, decreased return to scale. If the output turn out to increase more than the, proportional increase of the input, then that would be increasing return to scale. So that's what it is. So let's look at this example. So the example of the Cobb-Douglas production function, right? L to the power of alpha and K to the power of beta. So if I double L and K, right? So now my values of input L and input K will become 2L and 2K. So I can plug in L, I replace L with 2L and replace K with 2K, right? So I get this equation. And then I can move it a little further. Then I get 2 to the power alpha plus beta times L to the power alpha and K to the power of beta. So what you see here is that actually I can write it like this, right? This is actually just my original production function, right? So I can compare that. Okay, if I double both L and K, my output is my output more than double, equal to the double, or less than the double. So in this case, it is clear that it would be equal to the double of the original output if alpha plus beta is equal to 1, right? Then I will have constant return to scale if these two values added together is equal to 1. But if this one is bigger than 1, then my output will be more than double. So there will be increasing return to scale. If alpha plus beta is smaller than 1, then my output will actually less than a double. Therefore, this is decreasing returns to scale, right? So these are the conditions of the returns to scale. So we can also show this on the isoquants. So we have y1, y2, and y3. As you travel along any ray from the origin, the increment of the isoquant height tells us about the return to scale, right? So as you can see that you travel from here to here and from here to here. So depending on this and this, how much it increased. You know that increase from here to here, as you can see that the change in y and k, they are changed in the same proportion, right? But we need to also check the output. Are they also change in the same proportion or not? Do not confuse between these. Diminishing marginal returns. Remember, diminishing marginal returns, we fix one input and we allow the other input to increase. And then we look at the incremental change in the output. So that is diminishing marginal returns. Diminishing MRTS, we fix the output. So on the same isoquant, remember this MRTS is a slope of the isoquant. So we fix the output, fix the isoquant, the same isoquant, and then we change only one input. And we consider the incremental change in another input, right? That is a slope of the isoquant, which is diminishing MRTS as you move up or down along the same isoquant. Return to scale. We fix the ratio between the inputs, right? Is it double or triple or 4 times? And we know that both inputs will be changed, right? But we will just fix the ratio in which they are changed. Then we consider the proportional change in the output, that is the return to scale.